This video will be talking about signal symmetry, specifically odd and even as part of the signals and system series. So let's go ahead and do some quick definitions. Again, the discrete and continuous are very similar. One just uses n as independent variable, the other one uses as t, and I'll try to write both of those equations down, but the definitions are exactly the same. So let's go ahead and start by looking at the definition for even symmetry. And even symmetry basically says that if I've got a function x of t and I reverse the time, do a time reversal on it, or put a minus in front of its independent variable, it will stay equal. And of course the same thing would be true in the discrete. Okay, and then odd symmetry, basically odd symmetry, the other side of this coin, basically says that if I have a function x of t and I make it a minus, x of minus t, the result is the same as x of t except is negated. And of course the same thing for x of n. So putting a minus in front of independent variable puts a minus in front of the dependent variable. So that's called the odd symmetry. And this one is called even symmetry. Now let's do a practice. Take a minute and think about this. So if I give you a function x of n, and x of n is equal to 5n. Okay, pause and think about this and tell me whether this is even or odd. Okay, so hopefully you thought about it and you have an answer. And the way you do this, you say, okay, x of n I know. Let's go ahead and take a look at x of minus n. Well, if I replace my n with minus n, I'm going to get minus 5n, which basically tells me x of n is equal to a minus x of minus n, which basically tells me this is a odd symmetry. Now let's do another one. For example, let's say somebody gives you an x of t, and I'd notice I'm alternating back and forth, and have 20t squared. So now what is that? Is that odd or even? You do exactly the same thing. You say, okay, let's go ahead and replace t with minus t, see what happens. And you've got 20t squared. All right, now is that odd or even? Well, x of n happens to be equal to x of minus n. Therefore, by definition, this is a even symmetry. Okay. Well, if they give you some trick functions, we could do the same thing, but them is very common for us to be asked is, or having to deal with the fact that if I have an x of t equal to cosine of 200 pi t, is this even or odd? You do the same thing. You say, okay, what happens if I do an x of minus t? Well, that's going to be cosine of minus 200 pi t, and we know minus and plus cosines are the same. Therefore, this is an even function. Okay, let's say they come back and say, okay, x of n now is equal to sine of 200 pi. Let's go n in this case. Now the question is that odd or even? Well, we know sine x of minus n, we're going to put a minus n in here, and we're going to take a look at x of minus n and see kind of what happens. In this case, we'll see that sine of minus 200 pi n, we know that's actually tells us that x of minus n is minus x of n, which means therefore this is an odd function. Okay, so that basically takes us to the basic definition. Now the next question comes up, which is kind of a little bit trickier than these questions. Says, okay, you've got x of t, and your x of t now is 3t squared plus t plus 3. Ended up looking like 2, so let's go 2. So this is a function is given to you, and they're asking you, is this even or odd? You look at this thing and say, what if I put a minus t in there? You put a minus t in there, the values are not the same, so it is neither odd or not, nor even. But the actual answer is, it is has even part and has odd part. Now the next question is, okay, if it's got even part and odd part both in there, how could I find which part is even, which part is odd? We'll use the definition that we have from above, and we can come up with an equation that for any function given to you, you can go ahead and extract the odd and the even portion. So if somebody says, okay, so if I want an even portion of x of t, all I have to do is says x of t and go ahead and add x of minus t to it, divide by 2, because x of t and x of minus t, if they are even, they're equal, they add up to each other. And the odd part subtracts, so that falls off. So great. So that's that. So okay, let's just to be complete, what would be for x of n, it would be basically more or less the same thing, except instead of t we write n, and make sure we don't forget the square bracket. Okay, now the question is, well, how about odd? Well, odd, all I have to do, it says, okay, if you want odd part of x of t, then all I do is take x of t minus x of minus t divided by 2. Well, the even part subtracts and falls off. The only thing you left is the odd part. You have 2 of them, divide by 2, you get the right answer. And then of course x of n is a variation on the same thing. Okay, now we can answer the question up here, which part of this is odd, which part of this is even. Well, the odd part is going to be, we're going to take x of t, and we're going to say x of t, so we want to find the even portion. So for the even portion of x of t here, what we're going to do, we're going to take 3t squared, right, minus, plus t plus 2, that is the x of t. Now we're going to add x of minus t to that. Minus t squared is 3t squared minus t plus 2 divided by 2. Therefore, the even portion of this is simply going to be the 3t squared plus 2. So that's the even portion. What's the odd portion? Well, the odd portion is going to be, just replace the plus with a minus. Odd portion of x of t is going to be 3t squared plus t plus 2, that whole thing minus 3t squared minus t plus 2 divided by 2. So as you can see, t is the only odd part. So we got the odd part, we got the even part. Pretty straightforward. So you can apply that to any function, and you will get you will be able to break out the even portion and odd portion. So that's a symmetry. The symmetry is pretty important later on because we use its property to help us get through some problems a little faster and understand some properties of the functions. But for now, all we need to remember is that we have an even function, even symmetry, and odd symmetry. Most functions have both even and odd in them, so we'll use these equations down here to find them.